So square design is 4 times 3 plus 4, which would get you 16.
I need you to take some notes and pay
So we
attention to
gotta
things. I
write-
think you eventually got there at the end, but.
Just gotta do
Alright,
this, or
let's go over this. Not gonna erase that yet. I think, based on talking to everyone, eventually we all got to what common equation.
4x plus 4.
Okay, is there anything missing from that equation that you just said?
Y equals.
Okay. Is there anything we could put besides y equals?
F. Oh yeah,
F of x, right? So, or f of x equals, right? Here is something that I want you to start doing. Write down the general equation of the line first. If you say it's a linear function, same thing with exponential. Write down the basics first until you know what to substitute in for the different values. Which form of the equation of a line are you using? Slope, intercept. What is that? Y equals mx plus b. So on number 2, before you even write down this equation, you should have written down y equals mx plus b. And some of us need to write down some fundamental notes right here to make sure that we don't struggle with this again. Because if you're going to claim that it is a linear function, you are claiming that it has what kind of rate of change? Constant additive rate of change. Which is also called a what again? Common difference or slope. And I'm going to put slope here for now. M, slope. A bunch of us mentally looked like a fish flopping on land, struggling to figure out where to even start. But we forgot the most fundamental thing. What defines every single function? The what? The rate of change. And if you know what the rate of change is, you should instantly know the general equation. You've got to define your rate of change first. And if you didn't know that, or if you didn't remember that, you need to write that note right here, right now under Activity 2.1 in huge block letters. Identify the rate of change first so I know the type of function. Identify the rate of change first so I know the type of function. You got to do that. If you don't identify that rate of change first, you're going to struggle every single time. And from there, we got to remember what we mean by slope. Because there is a way to calculate slope. How do we calculate slope?
Rise divided by run.
So to calculate my slope, m is equal to rise divided by run, or how else?
The change of x over the change. Wait, the change of x over the change of y. What was the y over x?
Well, if you're rising, is that a y or an
Yes,
x?
the change of y
Okay.
over the change.
Tie
of
it back.
x.
Like, don't question it, or don't question it in the sense that you're just like, I have no clue. Go back to what you know. You knew it was a rise, didn't you? So mentally think about it. What variable rises?
Y.
The y. So it's the change in y. What variable runs?
X.
So it's the change in
X.
x. If you know one thing, always start there. And that's the thing I'm trying to get you to see is a bunch of us are struggling mentally to figure out what the equation is because you're starting at the equation instead of starting at the beginning. You cannot get to the end if you don't know where to start. Well, I'm telling you right here and right now, identify that rate of change first. That's where you should always start when trying to write an equation. Because once you know the rate of change, you know the type of function and you know the basic equation to start with. That's to calculate m. You've got to remember that what we mean by m is a constant additive rate of change. Because Ralston, if we are repeatedly adding, what operation are we going to use?
Multiplication.
Multiplication. So where's my slope here? M being what with the x? Multiplied.
Or repeatedly adding.
Repeatedly adding. I saw people struggling to figure out what my m was because they were trying to do the calculations instead of thinking about just what does m mean. It means constant additive rate of change, which means in this case, what are we repeatedly adding by? 4. By the way, some of us were stuck looking at this picture here. Is there another mathematical representation that can help us make sense out of what that rate of change was?
A table.
A table. Or a graph. We have n, and then f of n, the output for it. When it was a 1 by 1, the border was 8. When it was a 2 by 2, the border was
12.
When it was a 3 by 3, it was
16.
4 by 4.
20.
Remember how I said identify that rate of change first? Hey, what's the best representation to identify the rate of change?
Table.
A table. Now, if you make a graph out of it, the graph very quickly tells you what type of function, because if it's a line, it's linear. If it looks like a U, what's that U shape called again? Parabola. What type of function is that? Quadratic. If it looks like a flat and then it curves quickly up or it goes the other direction, that's what kind of function? Exponential. So I will say if you create a graph, right, because you could put these points in a list in spreadsheets and then have it graph it for you, right? If you graph it, then you'll see the shape and know the type of function as well. But I mean, I would start with that rate of change. Make a table. Stop floundering. Start with the basics. Got to know that rate of change. Make another representation. But notice this first 4 here, and I was trying to tell everyone this, don't just write down an equation. Explain what this equation means to you. Because that's just one equation that you can write here. There are lots of others that we're going to explore. So this 4 in this equation represents what?
Which one?
This first 4, what does it represent? Where are you getting that from?
The slope.
Okay, that is the slope, but what does that mean? Okay, talk about it in context.
Oh.
What is that 4 representing?
Constant additive rate of change.
It's a constant additive rate of change, right? Plus how much?
4.
4. Put that in context. Where are you getting plus 4 from?
The yo, y-intercept.
I thought you just said it was constantly adding by 4.
Which 4 is
You're adding 4 to every side, so I'm adding 4 here, 4 here, 4 here, and 4 here.
Yeah. Well,
Listen to what I'm saying, and be careful with your language. Am I adding 4 to here, and 4 to here, and 4 to here, and 4 to here? Okay, so I'm adding 1 to each side, which is how much? 4 total, right? So, you could say adding 4 what? Or adding how much to each side? 1. Okay, and you can, in the context, right, it's tiles. Adding 1 tile to each side, or 4 total. Right, you could have just said, we saw that we were adding 4 tiles every single time. That would have been completely acceptable. But I was asking for context, not just it's my slope, not just it's my constant additive rate of change. What does that mean in the context? I'm adding 4 tiles every single time to the border, right? But there's another 4 up here. Where is this 4 coming from? Where's this 4 coming from? So I'm adding an extra note here, repeated addition. But where's the second 4, that plus 4 that's right here? What is that coming from?
Y-intercept.
What were you going to call it? Your starting point, which is called the what here?
Y-intercept.
Y-intercept. So specifically which starting point is that?
You gotta go to 0.
Gotta go to 0, right? I didn't do that earlier, but 0, knowing that rate of change, if there was a 0 by 0 square, how many borders would, or how many, how much would the border be? 4. Which, I want you to think about it, that may not make a ton of sense at first, but if I literally don't have anything in the center, what would I still have from each of these diagrams? 4 what? Not
4 tiles.
Yes, partially. But what 4 tiles show up in every single one? 4 tiles that don't ever change. The 4 what?
Corners.
Corners. Right? We got 4 corners every single time, wouldn't we? So I would still have those 4 corners even though there's nothing in the middle. Right? For a 0 by 0, I would still have those 4 corners. So that does make sense in the context. So what is this plus 4? That is a 0 by 0 square. Still has how many corners? 4 corners. Notice there's a context to it. I need you to hear me on this. I don't do math just for the fun of math. I do math because it explains the world around me. Notice, you may not think that you will ever do tiling or this specific pattern. I don't disagree with you, but we are always going to do this stuff in context because math is all around you in different contexts. So the more context you see, the more you will be able to see the math in the real world. But we actually need to keep it in context. What does that 4 times x mean? Don't just say it's slope. Don't just say it's the constant additive rate of change. Constantly adding what? 4 tiles for every 1 in the n by n center square, right? Because a 4 to 1 ratio is 4. There's context to these things. Now, I want to take a second because I want to point out that Trista was actually looking at these tiles a very different way. Most of us were just adding the 4 every time, making a table, eventually just counting it up and figuring out that rate of change from there. But I want you to notice how I circled some of these things, because Trista, what you did is you looked at this one side, right? And then you looked at this side, and then this top side, and then this left side. And so you said, hey, that's 4 by 4. You can't see that, can you? You said it was a 4 by 4. But then what was the issue? Because there's not 16 tiles there.
Because I double counted the corners.
You double counted the corners, so what do we need to do?
Minus 4.
Minus 4. Is there a way to use that concept here? This would be a 4 by
3.
3,
And then minus 4.
and then minus 4 again, right? So there's 4 sides of 3 on each side, but I'm double counting my corners. What about, what would it be here? 4 times
5.
5
Minus 4.
minus 4. Well, if it's an n by n, going all the way out to n by n, what would I need to write? So think about it. This is a 3 by 3, and it's 4 times 5 minus 4. It was a 2 by 2, so it was 4 times 4 minus 4. So I've got an n by n now. I have no clue how many there actually are there, but how many are there going to be here?
4.
Well, there's 4 sides.
Oh.
You're thinking of a 4 by 4, which is, I would get 6, but I'm talking about an n by n.
You know to have 4
There's-
corners?
There's going to be n there. There's going to be what?
So you know you have 4 corners.
But not right here, I don't. Notice this is an n right here. So what would be the length there of that side?
N?
But it's not, n is right here, it's just here in the middle. I want you to look here, for a 3 by 3, how much was on each side? 5. When it was a 2 by 2, it was,
4.
when it was a 1 by 1, it was.
3.
So when it's an n by n, there's an n. There's something more to it though.
Minus 1?
No. It was 3 by 3, so it was 5. 2 by 2, so it was 4. So let's say it was a 4 by 4. This is what you started to talk about, right, Caroline? It'd be 4 times how much? 6. Where are you getting 6 from? I didn't draw it up there.
It's 3, 4, 5, 6.
Okay. But look again at this number and this one. This 3 by 3 and this one.
It's skipping. So it would be.
It skips 2.
When you say skips
Well, you're
2,
adding 2?
we're adding 2 to the n by n. So it'd be
Well,
n plus.
2.
Why would it be n plus 2 looking at this right here?
Because there's 2 sides. Well,
Two.
there's 2 tiles.
2. There's another word that we need to be thinking about. 2 what?
Squares.
Corners.
Oh,
Weren't there 2 corners on every side?
yes.
So every side was n plus 2. Does that hold here?
Yes.
Here?
Yes.
Here?
Yes.
It holds. Notice that's the only thing changing. So that's the only place I'm going to have a what? Starts with a V.
Variable.
Variable, thank you. Right? It's the only thing changing, so there's a variable there. So it'd be 4 times n plus 2. Do I just stop there though? Is that representing how many tiles are going to be here?
No,
Why not?
because you still got other sides.
Well, I mean, but that's why I did 4 times n plus 2. Right? So I got 4 of those n plus 2's. Am I done? Is that the correct equation?
Wait, you trying to do it linear, so no. Would it be y equals 4, or could you use n?
Yes, you can use n.
Switching is greater, so y equals 4n plus 2?
No. But, because here's the thing, you're trying to go back to a slope-intercept form, right? Did I ever say I was trying to use slope-intercept form here?
No.
There are other ways to write the expression.
So 4n
Slope-intercept
plus
is
8.
easiest. Look at the way that we wrote every other expression.
4
Why would you have to
Times.
minus 4?
Say it one more time.
Subtract 4.
Why?
Which is more.
That's what you do.
It's what I was doing, right? Wasn't there a minus 4 every single time?
Yes.
So would that minus 4 drop off?
No.
No. Why was I subtracting 4 though?
Because you were counting the corners twice.
I counted the corners twice, so I had to take away
4 of them.
4 of those corners. So there's another equation. So, but wait, I thought we said it had to be 4x plus 4.
That was just one way to write it.
Say that one more time, Trista.
That was just one.
That was just one way to write it. Is this also representing what we see in the border?
Yes.
Yes. Is this linear?
Yes,
How do you know?
because it's still being multiplied by the variable.
Still being multiplied, right? We're multiplying something by the variable, which means we are repeatedly what, Maven? We said we are multiplying right here, so we're repeatedly what? Adding. It's still a linear function, even though it's written differently, and I need you to notice that, because we're about to look at several other equations or expressions, and that's not one of them. There's some other ones that we can notice. All right, I think that is it that I want to talk about there. Yeah. Do we see how we can write multiple equations? Now, let me ask you this. Is this easier or harder than this one?
It's a little bit different.
A little bit more difficult? Okay. So what we want to, I want you to pull from this is, is there more than one way to write the equation?
Yes.
Yes, 100%. But what is probably the easiest linear equation?
And y equals mx plus
Y equals mx plus b. So identify your slope, identify your y-intercept. Okay? So there's more than one way to do this. Now, I'm going to quickly talk about 4. Actually, I'm not going to talk about 4. I hate that question. It was poorly designed. Go ahead and move to number 5. So what I want you to notice is, and I will establish this with this first one. So Wilma said, I must add 3 tiles to each of the 4 sides of the white square, which is 4 times 3 tiles. Then I must add 1 tile at each corner, so the number of additional tiles added to the design 2 square floor is 4 times 3 plus 4. Looking at this, what they're asking us to create is an expression that works for an n by n design. So when it was a 3 by 3, she said I added 3 on each side, right? So if it's a 4 by 4, we're adding how much on each of those sides?
2. Wait,
What?
1,
1 on each side, so how much total?
4.
2.
So it'd be 4 on each side, right? We're adding 1. It's a 4 by 4. So it'd be 4 on each side, right? So what would it be for an n by n? How would I rewrite this expression? You actually have already had this once. Technically, we're just doing an expression here because that's what they're asking for. Is that 4 going to change?
No.
So it's still 4?
Times n. I'm thinking plus 4, but plus 4 too.
I mean, where's that plus 4 coming from?
Corners.
The corners? Are those corners still going to be there?
Yes.
Okay, so plus 4. That's the same. It's the same as the slope-intercept that you just did. But they want you to write an expression to represent it for an n by n, so you need to have a variable in there every single time. Does that make sense? Okay, let's get to work on the rest of these for number 5. Get as far as we can before the end of class. Let's get to work.
Okay, so we're changing that zero. Alright. I must add.
Yep. You have one from Wilma, one from Howard, Tyler, and Tamara.